In this video, we are going to start on the task of basic classification using Tensorflow Keras API. So first of all, we need to understand what is classification. So we need to understand classification. Let's increase the font size. So classification is a supervised learning. First of all, comes under supervised learning because we are given a set of input and we also know the corresponding output. Like if we have say 10 images of uh, cats, it's difficult to draw here, so maybe I will take another simple example. Car. So we have some examples of car and some examples of bicycle. So we have few of these, like multiple car images, and we have labeled these as these are car and these are bicycles. So keep it B and keep it C. So we have say 10,000 images of cars and maybe 6,000 images of bicycles and some other classes, or we can assume just two class, and we train our neural network by feeding in input, and the neural network will try to understand what are the features in these data set that are different than images in these data sets. So ultimately, by adjusting their weights, the neural network will be able to understand the key differences between the class 1 and class 2. So this is why it's supervised, because we know we have the input image, we also have the labels, which is kind of a supervision. So we are supervising the machine to by giving the exact results. This is different from unsupervised learning, like clustering. This is classification. So you may be seeing uh, opening any news channel or news website, and you would see that news about one particular news is grouped together. Like you will see some news XYG event happening in some part of the world, and if you expand that, you will get all the websites, all different news channels showing the same news, but in slightly different ways. So those will be clustered together. So there, uh, the machine learns by itself to find some similarities between a set of data. Like we have some data, and the machine feels that these kind of data are somewhat related, and these are also related, and some other sets. So these are clustering examples, and these are unsupervised because we are not supervising the machine by providing input data as well as the corresponding output. So in this video, we will be mainly concerned with classification tasks. So firstly, it was supervised learning. And then we have the notion of classes, like car, bicycle, and bike. So these can be classes. and ultimately based on the given data, machine will try to predict the probability of a new data belonging to either car, bicycle, or bike. So when we feed after the uh, machine has learned to classify, which is computed from the neural network's loss function. So if we give image of a car and the machine uh, says that by 90% probability it's a bike, then in that case we will penalize the machine by increasing its loss function, and if it predicts correctly we will decrease the loss function. So the aim of the network will be to minimize this loss function, and by trying its model on different data set, ultimately it will be confident that now the loss has almost converged, and the machine the network is said to be trained, and then we can feed a new data to our network and it will predict the probabilities. Like we give a new image once the machine is trained or the network is trained. So this is our network. So for image cases it will be convolutional neural network, but let's take it as a feed forward fully connected network only for better understanding. So here data flows from layer 1 to 2 and so on. In case of convolutional neural networks which will be used for image processing tasks, these layers, instead of being individual nodes, these will be either uh, convolution layers or padding layers or pooling layers, and in the end we will have some fully connected layers like these, and ultimately it will predict the output. So this model is now trained and we give a new image. So let's say it's a image of a car. Then the model will, since we have three classes and this is class 1, this is 2 and 3, since this is car, ideally it should predict some value like 0.92 for car, so that is it is 92% sure that it's a car, and 0.7% it's a bicycle, and 0.1% that, sorry, 0.07 and 0.01 that it's a bike. So we will see that it's very much confident of this image belonging to class 1, which was the class of a car. So this will be the uh, final thing once the network is trained. So now let's write down the various steps. So first step would be to collect the data collection. Like we want to train a custom classifier. I want to train uh, a network to identify television sets. So in that case, we will need to collect thousands of data of televisions and maybe some negative examples also. And then we have to label the data collection and labeling. Sometimes you may find some standard data sets available, like the most popular is MNIST dataset, which is a dataset of handwritten digits. So the first step is collection of data and labeling of data. Then we will do data pre-processing, where we will maybe resize our images. Like we will, on the internet we will find different all different types of images. We need to resize them to some fixed size, or there may be one layer here which will just do pre-processing and resize images to a fixed size, because we in convolutional neural networks we will have these convolution operations defined for fixed size of images, and also in some other types of data, like which is not related to convolutional neural networks, like we are trying to predict the salary for a given position, maybe software engineer level 3. Then we will have some existing salary where in US we will have US dollar, in India you will have Indian rupees. So in the pre-processing we will bring them all down to one unit, so their currency needs to be converted to one currency. So similarly in images also we need to resize them, and also if we want to just train on color images or grayscale, so these kind of things we will uh, do in pre-processing step. Then we need to divide the data into train and test sets. So many people have different style of doing this. Maybe one can put 90% of the data they collected into training set and 10% into the test set. That would be a good number. Then once we have done with the pre-processing and data preparation stages, we need to build our model. So here we will just set up layers, like we need to define how many layers we want in our network. So this is not known beforehand, but you can start with some number, maybe 10 layers, and if we don't get good results we can increase our number of layers, and maybe we have insufficient data, so we need to increase our data set also. So building the model means setting up layers and then compile the model. Then we will train the model. Once we have decided the model, we have built our model, we will train the model with the given data and the given levels. And then the next phase is evaluation. So we will evaluate how our training is doing. How was our training? Was it good, not good? And finally, once we are satisfied with our training that yes, the error function has converged and the model is correctly predicting for almost all the cases, then we can uh, check with new data, make predictions on new data. So these are the various stages. This is pretty much generic for any kind of machine learning training, mainly supervised, any kind of supervised learning. This will be the pretty generic steps. It's not very specific to classification. So in the following videos, we will discuss all these steps in some detail. Mainly our focus will be on building the model, training the model, and evaluating the model. So we will look at these stages in detail in the following video. Thanks for watching.